So good morning all. I welcome you all for this session. Today also we will solve one problem on thermodynamics. IIT JEE main problem very recently came. Let us go to the problem. So the problem is came in question number 1, 2024, 1st February, shift 1. The present volume of an ideal gas is related to PV power 3 by 2 is equal to constant. So this is the equation. PV power 3 by 2 equal to constant. So this is called as polytropic process. Polytropic process. Next one is the work done by the gas when gas is taken from the conditions from state A. The conditions will be P1, V1, T1 to the final state will be B, that is P2, V2, T2. So the process is given by polytropic process. PV power n is equal to constant, that is K or C will be there. If you equate this one to PV power 3 by 2 is equal to K mains. So you will get, comparing this one, you will get n value is equal to index of a polytropic will be, process will be 3 by 2. So if you remember the formula for work done in a polytropic process, W is equal to P1 V1 minus P2 V2 by n minus 1. This is the formula for work done in case of a polytropic process. So if you remember, you can directly take the formula. Here n is equal to, so 3 by 2 we are putting. So here. So if you put 3 by 2 here, the equation will be simplified as P1 V1 minus P2 V2 by 3 by 2 minus 1. So this will becomes P1 V1 minus P2 V2 divided by 3 by 2 minus 1 is 1 by 2. 3 by 2 minus 1 is 1 by 2. Therefore, the work done will becomes 2 into P1 V1 minus P2 V2. So this will be the solution. Work done in case of a polytropic process is given by, for this polytropic process is given by, so W is equal to 2 into P1 minus P2 V2. So if you see the options means the first option is there 2 into P1 minus P1 V1 minus P2 V2 will be the correct option for this problem. Now let us understand how the work done will be derived. So work done, if you don't remember the formula, we can derive the formula also. So any work done in case of a process is given by PdV work is given by W is equal to PdV. W is equal to PdV. So the polytropic process is given by PV power n is equal to constant. So from this we can write P is equal to C by V power n. So P is equal to C by V power n is there. You can substitute here. You can substitute P value here. Then you will get P is equal to C by V power n. Now we are substituting this P is equal to C by V power n in the work done formula means work done will becomes a constant we are taking out of the integration. Integral volume will be V1 to V2 dV by V power n. So this is integral of x power n will be x power n plus 1 by n plus 1. Here also integral of 1 by v power, this will be v power minus n is equal to, we will get v power minus n plus 1 by minus n plus 1. So same thing here we will get c into v minus v power n plus 1 by minus n plus 1. The limits of v2 and v1. So if you apply the limits now, you will get v2 into minus n plus 1 minus v1 minus n plus 1 by minus n plus 1. So next thing is W is equal to C into this value, V1 minus n plus 1 minus V2 n plus 1 minus n minus 1. By rearranging the terms, you can take minus sign here common. So you will get it like this. So that is equal to, here now in place of C we can write, P1 V1 whole power n. So this one, in place of this is C value, P1 V power n, and this is also C value, that is P2 V2 power n. So if you substitute here, you will get that is equal to, so V power n, what is that, n into V power n minus n plus 1 will becomes P1 power n minus 1 plus 1. So you will get n is equal to V1. That is equal to V1 only. So same thing you will get here V1 only. Similarly, this value there is no, this value is there now. So V2 power n, V2 power minus n plus 1, V2 power minus n plus 1. So will becomes V2 power minus n, plus n minus n plus 1. So minus 1 as will get cancelled, we will get V2 only. So this value will becomes, this total value will becomes V2. So this total value will becomes, V1. So finally we will get this formula, work done is equal to P1 V1 minus P2 V2 by n minus 1. So if you substitute n is equal to 3 by 2, we will get W is equal to 2 into P1 minus P2 V2. So I hope you understand this problem. For any doubts and for clarifications, you can contact me. My name is Hariprasad Terivunda. This is my WhatsApp number and email ID. So you can subscribe to my channel for more videos. That is at HPRASADS, the YouTube search. So you'll get this one and you can subscribe here. Thank you for watching.